Ladies and gentlemen, good evening. Good evening and welcome, and thank you for coming this evening. It is wonderful to see a capacity crowd. Welcome to the University of Melbourne for the second lecture in the Melbourne School of Design's Dean's Lecture Series for 2013. My name is Tom Cavan. I'm Dean of the Faculty of Architecture, Building and Planning, host of the Melbourne School of Design here at the University of Melbourne. I'd like to begin proceedings by acknowledging the traditional owners of the land on which this event is taking place, the Wurundjeri, and pay respect to their elders and families past and present. I also welcome all visitors to this university campus, colleagues, students, and those who've come out of inspiration to hear about some exciting ideas in the transitions of design and construction. The presentation this evening is being filmed and will be available on the ABP website next week. Can I ask you to please engage us in the 21st century tradition? Take your mobile phone out of your pocket and turn it off. Thank you. Now, following the success of Sir Peter Cook's Dean's Lecture here in February, we are delighted to be hosting another acclaimed and innovative architect, Gregg Pasquarelli. Gregg is founding partner of Shop Architects in New York. His firm has experienced significant success in their business through a revolutionary business model, a radical reassessment of the way design and construction professions operate. So we're delighted that Gregg has been able to find time in his very busy professional schedule to take a whole week out, travel halfway across the world, and join us here in Melbourne and in our faculty. Our ability to bring international practitioners here to engage with colleagues at the Melbourne School of Design, with the students, and the broader design community is a very important part of our engagement strategy and how we connect with the bigger issues in the built environment. Of the several issues that we engage with, the changing nature of professional practice is one that looms large in our minds. The social contract that has underpinned professional practice has been extensively renegotiated over the recent years, and no profession at all has been left untouched. So debates and actions related to design and construction that we witness here in Melbourne on a periodic basis and in recent years are part of this renegotiation process. The quality of design, the costs of construction, and the realization of social value are components of that very fluid equation. So in his lecture tonight, Out of Practice, Gregg will discuss Shop's current projects and also discuss how the firm seeks to reinvent the business model of architectural practice and its delivery of value. The work of Shop is defined by a critical and direct engagement through design with construction potential and the exploration of new building techniques and processes to advance architectural objectives. So as both practitioners and educators, Shop's commitment to the challenging process of building seeks to prove that the beauty and technological proficiency are not mutually exclusive. Great architecture demands that design and finance and technology work together, and Shop is combining these forces in imaginative ways to create a new model of the profession. This reflects the framing of our graduate school, the Melbourne School of Design, in which 6 professional programs coexist and commingle, and the students interact across those professions with their chance to engage in this debate and contribute firsthand. Therefore, it's an exciting opportunity for us this evening to hear directly from someone who has acted on his reflections in these challenges. Through his practice, Gregg has pushed the architect's realm beyond form making and into software design, real estate development, emergent construction research, and the co-development of new sustainable technologies. Starting with an undergraduate degree unrelated to architecture, Gregg then progressed to receive an architecture degree from Columbia University as a graduate degree, and has held teaching positions at Yale, Columbia, the University of Virginia, and the University of Florida. He's lectured around the world. His work has been published in many places, both the normal architectural outputs you might expect, but also the New Yorker, Wallpaper, Metropolis, Wired, Fast Company, Surface, and many other places. This is the interest in this quality and kind of work. Shop's work is also in the permanent collection of the Museum of Modern Art in New York. So as a practitioner and an educator, Gregg's commitment to challenging the entire process of designing and building and realizing the future has made a convincing argument to a generation of architects that beauty and technological proficiency are not mutually exclusive. Before Gregg takes this lectern, I'd just draw your attention to another event this week in which we will explore some of the issues raised tonight. There will be a roundtable discussion at which you can be in the audience entitled New Technologies, New Processes, Architecture and Construction at the Deacon Edge at Federation Square on Thursday, May the 16th from 4:15 to 6:15. So you're all very welcome there. I'm not sure you'll all fit. But at this event, Gregg will be joined by a lineup of local experts and architects and construction contributors who will explore how architecture and construction industries are changing in the 21st century. So you can find out more about this on our website, the ABP Unimel EDU AU website. But please join me in welcoming Gregg Pasquarelli.
Well, good evening, is this on? Good. And clicker. Okay. Good evening, everyone. I've been in Australia a total of 9 hours so far, and it's a fabulous country. So, no, I'm very, very pleased to be here. Thank you for the very generous introduction, Tom and Don. Thank you so much for inviting me and hosting me, and to everyone here at the faculty and at the school. We are having a lot of fun in New York, and one of the great things is to be able to go around the world and share some of the things that we're trying out. Not everything is a success. There's lots of failures. We'll show you both today. But basically, I'll talk for about an hour and 5 minutes about how a young office of 5 practitioners got out of school 15 years ago, and what we were trying to think, and how we sort of went step by step to become a different kind of firm. So I think we should drop the lights and get right into it. Shop is the name of the office, but the name of the original founding partners are Sharpless, Holden, Pasquarelli. That's where the name came from, although we took our names off the office about a decade ago because we didn't want it to be about us. Now, even though there are 3 names, there are actually 5 founding partners of the office, and that's because the office is made up of 2 husbands and wives and the identical twin brother of one of the husbands. So this confuses everybody, including mostly our clients. So we made this chart to explain it to everybody. All 5 of us went to Columbia University. So this is the year that we graduated. The 4 of us were in the class of 94. Chris was in the class of 90. If you're inside the green box, it means you're married and you share things like bank accounts. And if you're inside the blue ellipse, you're identical twins and you share things like genetic code. So there's a seminal semester at Columbia where you're forced to work in a team of 2. It's the public housing project. Bill and I were housing partners. It was sort of the beginning of the firm, although having been the first, it was the same year that 1,000 Plateaus came out, and we tried to make striated space public housing and threw our project out 9 times during the semester, including a week before the final review. And at the end we said, you're a great guy, but the one thing we know is the 2 of us should never, ever practice together. But 20 years later, we're still together. I think that one thing that's important is if you can see underneath all of our names, all 5 of us actually had other careers before we went into architecture. And whether that's sort of important or not important isn't really the case, but I think what's interesting is the fact that I think it allowed us to freely adapt other methods of problem solving from other industries and bring them to architecture and design. And when you look at our design staff, we really try to search out people who have these sort of multiple degrees and people who can think across multiple realms of ideas. In 2007, we formed another company called Shop Construction. We had become fairly proficient in how to put buildings together using new technology. And so we spun off a new company and added a 6th partner. John Malley, and while they're separate companies, everyone works in an interactive way in our office. You're not even sort of in separate zones. You literally sit next to each other. People debate all the time. And then this last year in 2012, we added a seventh partner, Vishan Chakrabarty. So I finally found my twin, which is clear because we both have 11 letters in our last name that end in I. So, I think that the beginning of the firm came out of this idea of, this is sort of the history of architectural practice in the last 150 years on one slide. And I think that really our sort of criticism, and this has changed in the past 2 decades. I think it's starting to, this separation is changing. But, literally people sort of said, like, well, are you going to do sort of exploratory work and enter competitions for museums and do this stuff, or are you going to know how to put a building together that, at a large scale and complex and it doesn't leak? And that there was this idea that there was a separation between those two things we found to be really disheartening and not what we were interested in at all. I think we also were sort of critical of the sort of cycle of stylistic consumption or theoretical positions where while we love theory and writing and teaching, we didn't really like the way an aesthetic was always sort of applied to it. And that we felt that architecture is really a much longer game and not something that should follow a sort of intellectual fashion. And so the 5 of us really came together at the very beginning with this notion, sort of tongue-in-cheek at Bob Venturi, of a both-and firm. That there was a way that you could be a sort of guardian of culture, you could do research and theory and push the realm of design, but at the same time really understand finance and technology and how buildings go together and how it works in a kind of political realm. And that was really the goal for our office, not necessarily a sort of a purely aesthetic agenda. So we kept talking to ourselves about, well, what would the aesthetics be of a both-and firm? And what was this notion that we kept coming back to this idea of performance-based design, buildings that sort of looked the way that they worked. And we looked for models of that through history, through science, and aerospace, automotive, nature. There were lots of examples of it. And right about this time, the computers are now starting to get fast enough and cheap, well, fast enough that they were worth something to architects, and cheap enough that architects could afford them rather than the aerospace industry. And we started just writing our own software to begin to simulate these kinds of forces that were coming together in order to think about what performance-based design would look like. Now, often what we were coming out with were these complex curvatures, and we looked into architectural history, and of course there's a huge, long trajectory of complex shapes in the making of building. But of course, it was always done through labor, right? About someone sitting there carving or putting these things together. But that's clearly something that's much more difficult to do today. But we also tried to look at moments in aerospace and automotive and architecture and art when material changes happened or when there was a technological shift, and looked at the way in which new aesthetics kind of emerged every time there was a new way of putting buildings together. And that started to become the model of what we wanted to do. Now, of course, it really interested us in the sense that there were these very sort of complicit relationships between complex form and ornament and beauty and structural systems and assembly systems. And that was really where we were starting to focus the research of the office. But again, this stuff is very difficult to build if you've got to use labor, because labor is now just way too expensive to make these things. And so we were starting very early on and thinking, this is in the mid-90s, thinking about CNC technology and having the computer help us build the buildings that we were making. And one of the things that we learned very early on that became a kind of important driver for the work was the more and more we were going into this research, the more we started to realize that the standard ideas of architectural communication, this notion of plan, section, and elevation as your chief methods of communicating how a building goes together, were really becoming obsolete. And that, in fact, we had to start to think about what would the new drawings be that talked about performance-based design, not only as it operated, not only as it became a part of the city, but also about how you take a building apart in order to put it back together. And so more and more of what we started to do was think about what those drawings would be, how the machines could help us build it, and how we could begin to build a small practice from the 5 of us sitting in a loft above a Chinese restaurant on one of the exit ramps of the Queens Midtown Tunnel. You literally had to go through the back of the kitchen to get up to our office, and to then start to compete with much larger firms and going up against them and thinking about how we were going to get these buildings built. So I understand that the AIA, which is the American Institute of Architects, I believe it's the same title here, Australian Institute of Architects. I hear that you're way more progressive than the AIA is. So as I make fun of the AIA, please don't take it personally, all you members of the AIA here. But this is the only drawing in the AIA documents, in the official document set, which is more than 1,000 pages of documents in the US. And we would say that this is the single worst drawing in architectural history. This is a drawing not made by architects, but one made by lawyers who want to ensure that they have work for the rest of their lives. This is a drawing that puts the 3 main players in the production of space in a kind of acrimonious position where it's all about blame and not about solving problems. And so the way that we try to think about our office was, how could we begin to affect this diagram to begin to think of these new sort of business models and these new methods of production? So very early on, a very straightforward and easy thing was just starting to think about the role of consultants and how they helped inform our design. Now, of course, there's the role of the consultants, the structural and the services engineers and civil engineers and everything else. But it went much further beyond that. It even went to, when we start design, if we were going to build a building out of metal or brick, we go right to the bricklayer, or we go right to the metal fabricator, and we begin to say things like, how big do the metal sheets come? What are the 8 ways I could clip 2 sheets together? What's the radius that when I turn it that I get a loss in thickness or material? How many come in a box? How do I pick that box up off a truck and lift it into the factory? How do I make the assembled panels and get them onto the building? And all of those parameters we study before we ever draw a single line about what the building is going to be. So that immediately from day one, the method of how the building is going to be built becomes a driver for the form and the aesthetics of the building itself. So one of the early projects where we started to do that was something that's called the Young Architects Prize, which is a competition held every year for a young architect in the United States to build a pavilion at a museum called PS1, which is in Long Island City, Queens, which is right across the East River from Manhattan, and it's part of the Museum of Modern Art. And every summer, I don't know if any of you are familiar with this, but it's now sort of basically the top prize that you can win as a young American architect, and to build an experimental pavilion for the summer. And it's a great contemporary art museum. They fly DJs in from around the world, and then they throw these parties on Saturday, and it stays up for a whole summer, and it really kind of exposes a lot of sort of the young cultural elements or participants in New York to experimental architecture. So we did it in 2000, and the program brief was build an urban beach inside an 8,000-foot concrete wall enclosed courtyard in the middle of a factory district next to a museum. So we said, well, do you need sand and water to make a beach? And we said that no, in fact, if you thought about a beach performatively, the idea would be that there'd be places with shade, places to change, places to sit, places to dance, and places to get wet. And the idea was to take a series of surfaces and mutate those surfaces so that those programmatic elements would perform along that surface. So we did is there any way to drop the lights a little bit?
For the filming.
Oh, for the filming, got it, okay. You guys can see the image? Okay, fine. So what we did was we made a kind of model where we said it was just made of sticks, so it was a kind of A-B construction system. The A's are in red and the B's are in blue. All the dimensions of these curvatures were taken from mins and maxes of body shapes and lengths. One of the performative elements that the museum director wanted was that people would touch each other as much as possible. She said, I want you to encourage people to take their clothes off, and I want you to encourage people to smoke as much as they can. Okay. So there were even 60-foot ashtrays buried into the side of the walls all over here. And we built this digital model. This is actually the model. And then we made a series of drawings. This is not out of focus. That's one drawing is 32 feet long by 15 feet high. I'm sorry for not using metric. I'll try as much as I can. 5 by 11 meters. And what you could see was a kind of a system of outlines where you would follow a color-coded system. You would lay 2 pieces of cedar 2x2 sticks across each other. Every time they crossed, you hit it with a stainless steel screw, and you trimmed off the 2 edges. And so what you could see is that the pieces got made in the bands very quickly and got put together into this pavilion. This is the museum, which is an old public school, hence its name PS1. And this was called Dunesscape. You could see the object. There were sort of water elements that you could sit in, changing rooms, shading areas. And then we planted a forest of steel trees in the middle of the courtyard. And every half hour, the trees would hit, and there were high-pressure mister heads on top. And the entire courtyard would fill with the fog of the spray of the ocean. You could see the kind of smooth transition from seating to walls as the programmatic elements blended into each other. And then, your typical day at Dunesscape, which was quite a success. Now, the year before we did it, an architect named Philip Johnson actually did the pavilion at PS1. And it was a success, and he built a pavilion. He actually came out and DJ'd one day. It was great. And then this year, the year that we did it, it was wildly successful. We, had 60 or 70 articles and multiple TV appearances, and, it was this great summer. And as the summer was coming to a close, I was sitting in the courtyard, and I was thinking, and I said to the director of the museum, so how'd you guys do this summer? And she said, oh my gosh, it was great. We averaged 8,000 people every weekend came to hang out here for the big party. I said, well, how many people came last year? And she said, well, that was about 2,000 people came every weekend. So I just looked at her and I said, that's interesting. So an additional 6,000 people times 12 weeks of the summer times $10 a head admission plus an average of 2 beers and a hot dog or a hamburger. Wow, we just generated $1 million in revenue for the museum, and our fee was $15,000. What's wrong with architecture? But some really great things happened. Richard Branson came to see it and then hired us to do a piece for a building for Virgin, one of their first-class lounges at JFK Airport, which was moving it to the next step where we had almost an entire building within a building that was fabricated by computer. It had a kind of integrated system of HVAC and lighting and computer terminals and programmatic elements. To then a cultural building outside of Seoul, Korea, for Hangil-sa in the Hari Valley, which is a kind of really interesting building where you come off the hillside and enter from the top and go down a series of ramps around a 3-story high wall of books that become the vertical bookstore. And then there's sort of restaurant and gallery and exhibition spaces. To then winning a competition to do an academic building for the Fashion Institute of Technology in New York, where again we said, what's the performative element about design school? And we said it's not, some sort of overarching pedagogy. It's about the idea that you sort of exhibit your work, you critique your work, and you circulate your ideas. And so we took the outer 20 feet of the building and made it this kind of thickened facade that held all the crit rooms, all the exhibition halls, and all the circulation of the building, so that literally the performance of design school became evident in the thickness of the facade of the building, like a kind of great ant farm showing design for the entire to the entire city. One of my I don't know why I'm on a smoking kick tonight, but one of my favorite parts is you can't smoke in any buildings in New York. And one of the things that we found was that the FIT students really smoked a lot. So all these little tubes at the end become these outdoor smoking porches because you can't be inside a building, so that the students don't have to go all the way down to the ground floor between classes to catch a cigarette break. So they're still raising money for this building. We hope someday they'll do it. But I can't wait because I would just love it between classes. Like literally, this will be like an exhaust of smoke coming out of here. Be like, you know, the whole building will just sort of look like it's on fire. We'll have to let the fire department know that before. Anyway, as we started to build this stuff, you know, we're realizing that, again, the more and more that we want to build, we're still a very young firm. We're not going to get those Frank Gehry budgets. We had to figure out other ways to get around this stuff. And the more that we did that, the more we realized we had to get involved in the construction side. If we didn't want our buildings to get value engineered, the more we knew about what the contractors were going to do, the better chance we had of protecting the design. So there was a competition that we won to build a 4-acre park with a series of pavilions in a town about 120 miles outside of New York City at the eastern tip of Long Island. So it was a small fishing village, very rural town. This was sort of the front street, or main street and front street, and it had this 4-acre zone. And it was there's a ferry terminal here to go to Shelter Island, which is a beautiful summer colony. And this idea of having a sort of harbor walk that went all the way around to a high-speed ferry back to New York, a harbor master's house. There was a water park here that turned into a skating rink in the winter months. The town had an antique carousel, which is one of the great sort of fundraisers for the town. They sold tickets for it. And an amphitheater. We designed a marina, et cetera. But one thing that we did here was this little folly that the mayor actually asked us for. He wanted a camera obscura in his town. And we said, okay, well, we'll get to the camera obscura, but let's work on everything else. So it was an 8-year project, really tricky with getting government funding and cleaning up the site, et cetera, et cetera. You could see the Carousel House has these doors that open and close. They're about 4 meters high by 4 meters wide on Worm Drive, and they actually respond to the microclimate on the site. So they shut down as the winds come from one area, they open up as it gets hot, and the carousel now operates 365 days out of the year. You could see the harbor master's house, the water garden. We were able to reuse those mister heads from PS1 and out there, and they're still there a few years later. But then we had sort of earned the respect and trust of the client and said, okay, we're up to the camera obscura, the last building on the project. Can we use it as a pure R&D, research development kind of project? And he said, sure. So we said, look, let's see if we can make an absolutely pure performance-based building, because it's little and we can test it. So we wrote some software that helped us place the different programmatic elements that were needed for the camera to operate. And we tried to develop a kind of minimum surface that could mutate into all of those enablers of the program. The camera basically had a lens on top with a mirror at 45 degrees that could turn and cast the image on a flat table in the middle of the dark room. So this is the model. We'd like to call this BIM version 0.1. We actually just modeled all 2,830 pieces to the building. No two were alike. This is before Revit existed. And then we made a series of drawings, and these are the actual the actual construction documents for the building, where every different material was shown where it sat three-dimensionally in the space. And there were basically two kinds of drawings that explained to the computer how to make the parts, and then drawings that showed the contractors how to take the parts and assemble them together. And again, these are the actual drawings from the set. And the fascinating thing was that, fold, weld, bolt, screw. And we were able to even figure out what sort of composite parts were made. We could figure out the weight that they were. We never made it heavier than what two people could lift and put in a place, so that no specialized equipment was needed on site. So basically, every part in the whole camera was made by the computer. No two were alike. And every part arrived sort of pre-cut, pre-slotted, pre-drilled, pre-numbered, like the most kick-ass piece of IKEA furniture you have ever seen. So this is actually for the Cooper Hewitt Triennial. They asked us to make a piece. Those are all the parts that made the camera itself. Even the formwork for the foundation was milled and ready to go, so that the contractors just had to shoot 4 points. They fully templated out where to dig. They dug the holes, the formwork went in, and most of the instructions for putting the building together were actually milled right into the material. So it would have on it weld, 1/4 inch fillet weld from here to here. And they would put it down, they'd put the pieces together, it would line up, they would snap together, and the guys would weld. So it was remarkable because the building went together in about 6 weeks with 2 guys, and there were 2 fascinating things about it. One was we looked at the set of construction documents when it was done, and there was not a single dimension string on any drawing because dimensions were now meaningless, because every part, it was modeled at full scale, and every part came ready to go together at full scale. And the second thing was that the contractors had no tape measures on their belt while they were building it, because they didn't need to measure anything anymore. Everything was there, and it went together incredibly quickly. The only mistake, at one point, someone pulled the wrong piece out, and one of the guys on site heard a saw start. And everyone came running out of the construction trailer, stop, don't cut, because they knew that if you cut, they just had picked the wrong piece up and they thought it didn't fit and it needed to be trimmed. Once they stopped that, everything else fit together. So the building went together, and it was incredibly interesting to get a super highly customized building at completely standard construction costs. And not only that, what was interesting, because this was a public project which faces really strict and difficult onerous rules for contractors in the US bid process. The fascinating thing was that the 4 bids came in within 2% of each other. Now, why is that important? It meant that we had removed all the risk from the contractor side and we removed the risk by thinking through how the drawings would be made. So this was fascinating. Not only did it come in at a standard cost, but no one didn't know what they were going to build. They could tell exactly how much material, exactly how long it would go together, and by looking at those drawings, they understood how it would be put together. So we realized that this was an incredibly valuable tool and an incredibly valuable way of putting buildings together. Now, no one would argue that you put a 60-story building together like this, or a million square foot arena or something. But what we started to learn, and this is a very important point, was that you can make 80 or 90% of your building very standard construction that's very easy for everybody to understand and put together, and then take that 5 or 10 or 15% and build it like this and put it in the right place, and it makes the entire building look like it's an unbelievably complex and special kind of project. And that's been a strategy that we've used to sort of push the agenda forward as we moved into larger and larger projects. And we started to realize that, we were coming back to aerospace. This is exactly how a plane gets put together. And that became kind of our sort of inspiration for moving forward. And here you can see the park when it got finished. Now, that was interesting because then there was a very large competition to do a 2-mile, this is Lower Manhattan, so this is Brooklyn, here's Wall Street, this is the Trade Center site, this is the Battery. So there was a competition to do a 2-mile esplanade along the East River, and one of the requirements for being in the competition was that you had to have finished a waterfront park in the state of New York, which that little Greenport project was. So we were able to enter the competition, which we were lucky enough to win. And what was fascinating, I mean, if you look at this, this is some of the only truly south-facing waterfront property in all of Manhattan because of the configuration of the island. And here's Wall Street in the financial district, which is the 3rd largest central business district in the United States, Midtown being the first, Chicago being second. A 5-minute walk from a central business district, south-facing waterfront, unbelievable views. And this is what the city was using the property as. So there was no way to walk through here with these sort of infrastructural broken links. There's an elevated highway that they were parking trucks and using for garbage dumps and salt piles. There were beautiful 18th century squares that were being used as parking lots. And then here you see lots of housing, mostly middle income, lower to middle income kind of housing in this area, and people who have very little open space available to them. But what you saw was up to 14 layers of chain link fence between where people lived and the waterfront. And they said, we got to do something. The Bloomberg administration said to us, we've got to do something to fix this. So what we did was we leased a helicopter, and we had them fly us over all 280 miles of waterfront property in the 5 boroughs of New York. And we just shot pictures and made a taxonomy of waterfront types and basically came up with the ways in which some work and some don't work for connecting people to the waterfront. So the existing condition was a street that worked way back in here, a sort of service street for these towers. And then the problem was this incredibly wide gap between the curb level here and here, a highway above, truck parking underneath, series of fences, and then sheds on the piers whenever they went out to the front. So we said to the city, look, get rid of the parking, add trees wherever you possibly can, get the bike lane. They're trying to build a bike lane that goes all the way around Manhattan. And instead of, we couldn't take the highway down. It serves several important purposes. We said, instead of complaining about this dark highway, well, we tried to get it down, trust me. If I weren't being filmed, I would tell you why we couldn't get it down. But we said, okay, instead of complaining about this thing, let's think of it as a free roof. And let's hang lightweight walls off of it, and let's bring sort of cultural and recreational and community programming out to the waterfront. So almost to bring the city out to the water and then bring the water back into the city. And then the last idea, because you can't expand the size of a pier for the environmental impact that additional shading would have on the plant and animal life below, we said, why don't we turn all the piers into double-decker piers so that you get a sort of 2-for-1 of recreation space on the waterfront for every square foot that you cover. The city was really highly suspect of these ideas, but somehow they commissioned us to keep going. And we spent 7 years battling with the city on every single part of this, but eventually getting amazing support and getting it done. So it's being built in sections, and the first section opened about 1.5 years ago. So you could see we developed this kind of furniture system with ductile concrete that's sort of these crate box. This was really the beginning of the trade port of New York. And then these series of precast concrete walls that are able to hold the soil so that we could get enough depth to get tree roots in there. And then you could see that we pushed the planting in as far as we possibly could based on where the sun angles would give enough light underneath the highway to give as much green as possible. So here you can see you remember that shot with the truck with the garbage piled in front of it? That's almost the same exact spot that you're seeing right there. And then one of my favorite things in the whole park, I have to say, is, I don't know about you guys, but like whenever you go to a waterfront park, you always get really frustrated because you sit down at a chair and the required railing height, which is 42 inches for us, is exactly where your eye looks at the horizon. So we argued and battled and said that all seating on the waterfront should be bar stool height so that you sit up high. And again, that was a 3-year battle. But you can see what we did was we took the railings, and then they go from 6 inches to 18 inches. We got these bar stools up, and they're wide enough that you could plug your computer in. There's Wi-Fi there. You can pull open the newspaper. You can eat your lunch. And they are always the first seats that go. And now the city is so shocked at their success that it's part of their policy to put bar stools around the entire island of Manhattan, the victory. So, and then one of the other things about coming to a waterfront, especially at night, like for me, going to the waterfront at night is amazing because the light levels drop. There's the sort of twinkling on the, of the boats and of the water reflecting the moon, whatever it is. It's all about bringing the light levels down. But there has to be enough light that it's safe. So the idea here was that no, you could never see a light source in this project. So every light source is buried inside the objects and reflects off a surface onto the space. So one of the big things we did was we convinced the city to paint the main girder of the FDR Drive lavender. And the idea is that the lights are hidden up in here. They hit the lavender girder, and then you see this beautiful light that casts along the entire esplanade as you walk. It's incredibly romantic, and I've been told that anyone who goes on a date there gets to make out before it's over. Sorry, I just lost my cap. It was very romantic. So you can see the lighting in the planter walls. And then the Doubledecker Pier. So Pier 15 is the first one of them. So it's these series of glass boxes that sort of hold up this sort of flying wing, if you will. These will have maritime education centers and cafes. These are a series of we call it the Lido deck, the sort of sunning area where it's directed due south. The planters out there. And then the glass boxes have green roofs that become the lawns that you can picnic on as the glass goes through the upper deck. And so basically this is invented space. This is outdoor space in a city desperate for outdoor space. And the fascinating thing is, like a square foot of dirt in Manhattan is worth $10,000, $20,000, $30,000 a foot, depending on the FAR. And we were able to produce this for about $150 a foot. So for us, it was like inventing new Manhattan at an absolute bargain price. And it's incredibly well used. That's the Brooklyn skyline you can see across the river. And Van Valkenburg's new Brooklyn Bridge Park on the other side, making a connection. There are places where you can get down towards the water. And then one of the big criticisms was, well, who wants to go to a park with a giant thing over your head? And we said, well, look, if you just make it beautiful, it'll be great. So we used recycled material in this kind of red material, this red color, and it undulates based on the programming above. And then we just put very inexpensive lights above that bounce through the structural system and then cast this incredible glow. And that's what the pier looks like. Super affordable. And almost 3 acres of open space for almost nothing in cost. And now they're thinking about building these all over the city. But doing things like that, so this is Lower Manhattan. That's our pier, the Park Pier. Here's where our esplanade goes. There's a large development here called the South Street Seaport, which was this kind of mall built in the 80s on the waterfront that has really been a bit of a failure. And it's in private hands, not public hands. So that company then was so interested in what we were doing in the park, they hired us to reimagine what could happen on this pier. And quickly it was this idea of moving a historic building that's a waterfront marketplace here, putting a 4-acre open park in the middle, and shifting all the FAR into this sort of slender tower that would be a hotel and residential building with a series of retail pavilions underneath. So here you can see as you're on the elevated highway driving through, retail below, a boutique hotel here, and residential, a luxury hotel here and a residential above, all in this sort of terracotta-clad superstructure that changes based on the program behind it. So this project was going ahead very well, and then the GFC hit. We just call it the mess. In 2008. And our client, which was a company called General Growth Properties, market cap of $66 billion, went bankrupt in 4 weeks. $66 billion to zero in 4 weeks. The largest real estate bankruptcy in the history of the United States. And not because they weren't making money, but because they had purchased $20 billion in assets in the early 2000s, all with short-term debt. So all they needed to do was refinance their debt, and there was no way to refinance it, and the whole company collapsed. But fortunately, a new company emerged, the Howard Hughes Corporation, and we've started to rethink what the buildings could be. And this is the first in a series of 5 buildings that are going to be built with this sort of articulated glass facade with large-scale pier doors and a kind of street system that moves through, that opens up the streets and brings the water in, opens up these views to the Brooklyn Bridge. And I wish I could show you more, but I'm not allowed until it becomes public. But then working on these projects and figuring out how to make them, we got to know more about the Bloomberg administration. And then Michael Bloomberg, who owns Bloomberg LLP, he happens to be our mayor and owns the media company, asked us to work for 6 months on a project for him in London for his new London headquarters. So again, a fascinating project. We brought it all the way through schematic. There were 5 architects that started, and then they cut it to 2 architects who brought it all the way through schematic design. But it was this idea about how their company works and a media company locating itself in its environment and the way it connected both to the city and to the street, the way in which the offices were organized around these kind of sloping atria. And then in a very strict environment, because it's right near St. Paul's Cathedral that has these protected view corridors, how to make a sort of iconic element on the skyline, but while still respecting all those restrictions. So this was a project that we thought we had won, and were told that we were won on a Friday, and somehow by Monday, Norman Foster had wrestled the project out of our hands. You know, I give him all the credit in the world. I learned a lot of what I'm going to do when I'm 70 to screw over some 40-something architect. You know, no shame in losing to Norman in London. He's a phenomenal, phenomenal architect. So we continue to think about the way we were helping our clients in working in their businesses and pushing the envelope of what they were doing. And we kept realizing we were making a lot of money for our clients, but we're being paid architecture fees. And I think that one of the things that we have to remember as architects is that, you know, what I think is really great about being an architect is that we're amazing generalists, right? What our greatest skill set is that we're good at a lot of different things. But yet somehow I think that we've been pushed over the last 20 or 30 years to be more specialists, to be just about what the aesthetic of a building looks like or the wrapper of the building looks like. But that's not our value. And I think that a lot of territories have been sort of systematically stripped away from our role in the making of space, and that we need to really think about how to recapture them. So we figured, is there a way that we could sort of joint venture with one of our clients? And we've done this on several occasions where we've said, well, we'll bring our knowledge and know-how in exchange for equity in the project. And we'll put everything at risk, but we promise we'll deliver you a phenomenal building, but then we want to share in the profits of what we deliver. So the first time we did that was a building called the Porterhouse. And so there was a 6-story, 100-year-old warehouse building, and there were lots of guys chasing it that wanted to do something with it. And it was 6 FAR on the site, so it used its maximum amount of square footage that was allowed on the site. But there were 2 historic buildings to the south where we said, well, we can buy the air rights and transfer them on top of this building. And there was a 120-foot height limit and a 15-foot setback requirement. So the only way, and I think a few less people had that idea, but a lot of them still had that idea. So the only way to sort of increase the amount that we could build in order to project having a little bit more revenue in order to then bid a little bit more on the original building, we had to figure out how to make it bigger. So the only way that we could really build was sideways. So by buying an air and light easement over these buildings, we started pushing this out. The problem is that the further you push it out, you sort of have a diminishing return because the cost of the cantilever becomes so expensive, it begins to take away the projected profit, and therefore you can't bid more for the property, if you will. So on this project, we were working with Bureau Happold, and Happold came up with a really sort of clever idea on moving the kind of core to the center of the building, putting half of the piles in tension, half in compression, and making a sort of 2-story couple where we had a 6-story old building and a 6-story new building that connected through the floors with this couple that kept the overturning of the building from occurring. And by doing that and just getting those few extra square feet, it allowed us to bid just enough to sort of win the project over the other guys. So The typical plan is just a very simple core. We were going to convert it into condominiums with retail at the base. It's only a 50,000 square foot building, very modest. But all the apartments have 3 exposures with this simple core in the center, fairly large apartments. And so now we had this kind of old historic building and a new building. And our idea of contextuality was that it should look nothing like the old building whatsoever. And we said, well, what do we want to do? Well, we said, well, we haven't done a metal building yet, so let's try metal. And we wanted to do zinc. So we said to ourselves, like, well, we went to the zinc manufacturers, and they were saying, well, it's X amount more for a zinc facade. We were saying, well, that seems ridiculously high. Like, zinc only costs a little bit more than steel. Why is it double in price? And they said, because we don't want to do zinc, so screw you. That's what it's going to cost. So we said, well, where does zinc come from? And they said, well, most of it comes from France. So we got on a plane, and we went to France, and we bought 1,000 sheets of zinc and brought it back to New York. And we designed the entire building around the unfolded panels of zinc so that you either fit 1 on a panel, 2 on a panel, or 3 on a panel. You had about 22 protoforms of shapes in order to make this rain screen system, and about 400 unique shapes, and about 4,000 parts in total. Now, this would be impossible for us to create the shop drawings for 400 different shapes. So this was the first time we used Solidworks, where we had a sort of parametrically driven model type where you just fed all the difference in a spreadsheet, and that went to the computer that cut out all the parts. And then every part was labeled with a code system that became the instruction set for how the building went together. So the actual architectural details on the building that still remain there today are the instructions of how the pieces go together. So we started putting them on one side and went all the way around. And when we were done and got back to the first part, we were 1/32 of an inch off with 0 shop drawings. And while the worst brick wall you could do at that time was about $50 a square foot, a typical metal building would be about $70. They wanted to charge us $100. A nice curtain wall, like on the Richard Meyer building, was about $120. We delivered this one for $43 a square foot with all the detail and all the custom things that we wanted to do. So here you can see the building. And one of the things that I really like about the sort of interaction between old and new, there were setback terraces, and you basically have 3 panel sizes, 4 window sizes, and then these white elements are light boxes that glow at night. There are 2 light box sizes. And one of the things that I thought was really important was that we pushed the glass back 14 inches from the facade to give it that kind of texture and play with shadow, which I think is important in the success of how that building reads against the historic building. Now, the issue, though, is that you push glass 14 inches back, you're suddenly creating ledges. And, of course, we have a pigeon issue in New York City. So I called the Museum of Natural History, and I asked them, is there an angle of repose that a pigeon will not land on? And they said, yes, in fact, it's 34 degrees. So we built we put a piece in there, and you saw the codes. All the code systems explained where it was. So this code system was PS, like 273, whatever it was, which stood for Pigeon Slide. And I've been in the building. I've actually been in there and seen a pigeon try and land, and it goes right off the end. And what I'm happy to say is it's almost 10 years later, and there's not a single turd on the facade of the building. So we did the collateral materials, we did the interiors, we brought it to market, and it was fascinating because we were up against, let's say, 3 or 4 other very well-known architects at the time, and our building outsold them by 17% on the sales. And it cost 0% more than completely standard construction. So it was it was the first time we were able to actually measure the value of design and how we could push it against other methodologies. And that was taken, I think, last summer. Still looks good. That's led to larger projects. This is a 3 million square foot mixed-use project we're doing in the Williamsburg section of Brooklyn. This is the Domino sugar plant. We've proposed bringing the street grid of New York through and a new road along the front, new street along the front. and a 6-block park by James Corner. We work often with field operations. We work with Arup a lot. Several of the projects were with Arup. So these are the firms that we work with. If you don't know James Corner, he did the High Line in New York, which you may know. So this is a really interesting project that we're about to get approval on. I mean, this stuff in New York is like, they think we're nuts. But anyway, this was just released about a month ago. And I don't know, there's a very well-known blog in the United States called curbed.com. And it's sort of like real estate, property, architecture, urbanism all together. And the fascinating thing is within an hour of us, here you can see, within an hour of us publishing it, they changed the rendering to look like this, where it now is S-H-O-P. So, and of course, then the protesters came out. I can't believe they're making the buildings look like that. Idiots. Anyway. There are other firms that we've worked with where we started to become an advisor to the firms. This is a project for a large internet search engine company in Mountain View, California, who should remain nameless, where the founders asked us to really push what an office building should be. They said if it was LEED Platinum, the highest rating you can have for sustainability, that would be a complete failure. They wanted 2 generations beyond that, and what would that mean? We studied everything from the efficiency of having slides to move between floors, to landing, to dirigible commuting from downtown San Francisco into landing pods on the roof. An amazing research project, but where we were able to sort of write our codes to show that how you organize the priorities in the building radically changed the form. And it was the only way that this client could really understand the relationship between form and performance and architecture. And so the building ended up being this really sort of interesting kind of performance wing of the way in which their company operated, but also sort of highly sustainable project. This was also another casualty of the crash in 2009. But we then did a 250,000-foot interior project for them, and they're rezoning this campus now, and hopefully we'll be doing a new one soon. But we took all that research and entered a competition in Botswana, Africa, where we took the same ideas and made a kind of performance envelope. Of course, it's in the southern hemisphere, so we had to flip everything to the other side, which took us we're very slow. It took us a little while to pick up on that. And a really interesting project with these beautiful 150-year-old trees. We mounted everything up so that the parking could be shaded, and underneath, cut these holes in the platform so that the trees come up through and make these shade gardens, and then all the buildings are connected with these glass bridges that go through the treetops. And this one, it's so funny, it came down to us and Norman Foster again, but this time we won, yay. So we're building it right now, it's under construction. Again, highly sustainable facade system, incredibly performance-based in the relationships of the shapes. These are some of the parametric models where we were taking traditional Botswana basket weaving techniques and showing how this could become the facades, the wall systems on the interiors. And a lot of this is about knowledge transfer. We're going down to Botswana, we're bringing equipment, we're sitting in the schools, we're working with people in the offices and sort of teaching them how to use this equipment. Whoops, sorry. Here you can see what some of the interior spaces will look like. These are some of the first mock-ups of the computer fabricated parts and the building as a whole. So under construction now, and hopefully we'll open in about a year. So last project I'm going to show is the Barclays Center at Atlantic Yards. So for those of you who may or may not know about this project, this is a 6 million square foot, 600,000 square meter project in downtown Brooklyn that was started in 2003. Frank Gehry was the original designer and master planner of the project. And the key thing here was that Brooklyn lost its sports team, the Dodgers, to Los Angeles in 1957, and people are still angry about it. So the developer brilliantly bought the New Jersey Nets, who are an NBA team, and decided that he was going to move them back to Brooklyn and wanted to make this basketball arena the centerpiece of a 6 million square foot residential development. So Gehry did a brilliant design for an urban stadium, where literally 80% of the stadium was buried inside the bases of these towers. So that only 20% of it, one spot on this side and one spot on this side, was visible from the outside. And I think it's a great way to integrate a stadium into an urban context. So this thing was fraught with 34 lawsuits against this project, people chaining themselves to the building, major demonstrations, a 10-year fight for the client, front page of the New York Times for years and years and years as one of the fiercest battles in New York's history. And then what happened was the crash hit in 2008. And then, I'll go back, and then basically it wasn't, and the newspapers still don't get this right. They say they couldn't afford the Geary building, so they had to go somewhere else. That wasn't the case at all. The problem with the Geary design was that it was 4 major buildings like this holding a bowl in the middle on these very large foundations. And in 2008 and 2009, those 4 buildings were not financeable. So you suddenly had a building with no foundations and no walls, and it needed a redesign. Now, our client asked Frank to redesign it, which he was going to do, but obviously would take some time. And this is now the spring of 2009, and the problem was that the tax laws in the United States were going to change so that if you didn't have the building in the ground by December 31st of 2009, your stadium bond financing was no longer tax deductible. That would have been a $400 million hit to the project. So the problem that our client had was he had 8 months to redesign a project and get it in the ground. So he went to Hunt Construction, who are probably the best design build contractors of NBA stadiums, and asked them, you know, like, what do I do? Is it possible to do this? And they said, there's no way in the amount of time. He said, the only hope we have is if we fly around to every NBA stadium that we've ever built, and you pick one that you like that happens to fit on the site in Brooklyn, and we have the steel drawing so we can order it tomorrow, and maybe we have a chance of doing it. So that's what they did, and the stadium that they picked was from Indianapolis, and this is what it looked like. So, and it was Ellerby Beckett, AECOM, a very, competent firm, but you could, as you might imagine, the city of New York was really upset. They felt that they got baited and switched, and somehow in the next day it was literally on the front page of the New York Times of this travesty committed by the client. So a month later, we got a phone call, and they came to us, and they said, we were told that you might be able to solve our problem. And we said, well, yeah, we'll redesign the stadium. They said, sorry, the steel's already been ordered. So we turned the project down. We said, well, we don't do skin jobs, but we had this great conversation. Forest City was an amazing client, really phenomenal people. And the meeting ended with our Bruce Ratner saying, you guys are terrific. I'll call you in 3 years when this recession's done. We'll definitely do a stadium together, or do a project together. So that night, my partners and I went out to a bar and had way too many martinis. And at the end of that night, we pulled out paper and we started drawing. And we said, there might be an idea. And we started sketching. And the next day, we called them and we said, you know what, it's Tuesday. We'll work until Friday. And by Friday, we'll send you 1 image and 1 image only. And if you like it, you can hire us, but we want the whole thing. We then want the inside, we want everything, we want to completely redo whatever we can, pull the steel apart, pick whatever. So he said, you'll do that for us? I said, yeah, we'll do that for you. So we worked. This was sort of the box that we were given, and I've only started showing this very recently. This is the piece of paper that we drew in the bar. And as you can tell, it's very, very well done. I mean, if you just look at it, there's a lot of what eventually came into the whole building and so on and so forth. We had an idea. Now, the funny thing about this piece of paper is Toyo Ito's name is here. And none of us have any idea why we wrote down Toyo Ito. If anyone can come to me after lecture, after you see the rest of the design, and give me any inkling why Toyo Ito is connected to this at all, I'd be thrilled. But the funny thing is then, of course, we started showing this in October, and then Ito won the Pritzker. So, you know, it's clearly the lucky charm of being on the shop piece of paper that did it. So we promised Stephen Hull will put his name on our next one. Anyway, the idea was to take the kind of vertical element, break it into horizontal bands, begin to start to open up from the concourses to views of the city, make a huge entry plaza, and then a large canopy that became almost sort of what we call the arms of Bernini, but hip-hop style for Brooklyn. And to then cut a large oculus in the front, where as you come out of the subway, you can look right through with a giant open sort of vomitory here that looks right at the scoreboard, so that from the outdoor public space, you can see into the bowl and into the scoreboard itself. And then as you come out of the subway, your first view is up through the oculus and at the upper ring and the sky. Now, for an 18,000-seat stadium, we put 0 parking spots in, 0. And the thing that I think is really great about this arena is that it clearly prioritizes those who come by public transportation over those who come by private transportation. The aesthetic was looking at the kind of industrial history of Brooklyn, the idea of technology, but raw materials sort of set against each other. That's the original sketch that we sent to Forest City on that 3 nights later. We won the project then. This was set, then he gave us 7 weeks to design, detail, and cost the entire project. That should have taken 7 months. We had 26 people working day and night in 2 shifts for the 7 weeks. We got to the end, we costed it within a delta, and we had the whole project. And 3 years later, that's the building. So, I mean, what's pretty interesting is that sort of connection between the 3. So the building ends up being 12,000 uniquely shaped panels of basically a core 10 weathered steel. And you could see that the facade turns in and becomes these sort of streets, and then from we sank the bowl so that you can look. That was actually Ellerby Beckett, AECOM, worked with us, and we were in partnership. You could see inside and outside from any portion of being, so you really have this kind of interaction. And then the interior was all about sort of the Brooklyn night. This notion of these are the ribs of the steel coming in to become the light rails, the sort of minimalist materiality of the different concession stands, the main entry, the different clubs that actually puncture right into the bowl. And then one of my favorite things, which was that we convinced them that the entire arena, all the seats, should be black. And the argument, for those of you who may or may not know, Jay-Z is one of the owners of the basketball team in the arena, and he was incredibly helpful, an incredibly smart guy who really cared about design. And we said to him, look, sports is basically theater with an unscripted ending. And so why shouldn't this feel like black box theater? Why shouldn't all the attention be on the stage of the court itself? And by making it all black and turning the uniforms into black, we really felt it would reposition the team. And then the folded panels that had lights embedded on the inside. And then shop construction getting involved in actually how to make it with the CATIA models, the 12,000 unfolded panels, the multiple different types of mega panels. So it was 12,000 of these panels, making 921 of these large panels that got put together with the backer. All of the drawings were done by shop for the cut files. And then we helped set up a factory where the panels would go on this sort of dry cleaners rack and go through 15 wet dry cycles a day for 4 months to put 10 years of patina on the panels. All numbered and cut by computer, assembled. We wrote our own software for an iPhone app that you could walk up to any panel at any time, scan the panel, the 3-dimensional model came up, you knew exactly where it was in the weathering process, the assembly process, where the panels were, and how you could put them on the building. So complete transparency from the CEO to the guy with a wrench putting it on in the field. And here the panels would get shipped. We cloud scanned the steel as it was going up, and then aligned it to our digital model to find out if any of the tabs that were going to hold the panels were in the wrong place. And 15% of them were, which would have resulted in a 3-month delay in the project, but gave us enough time to realign them and make sure they were right in the right spot by doing the full building cloud scan. So the panels came on. Here they go as they are being assembled. See the patterning. And then the Oculus became this, most arenas have, certainly in the States, have the digital boards on the outside, but because this is sort of in a residential area, we wanted to turn it to the inside and really focus it. So we made this argument that all the digital boards should be on the inner ring. This is a super complicated piece. This is about a 32 meter by 80 meter cantilever. But really getting into the details of how this was being built. The fascinating thing was that the guys building it didn't want drawings anymore. They just wanted us to come up there with the laptops or the iPads and just show them the model. And they were literally putting it together, looking at the iPads. You get a sense of the scale, the pieces going together. And then when it was finished, from the back. Here you could see it in its context. Coming down Atlantic Avenue. And then as it turns to game time and the lights go on, you can see the sort of reflected lights from the on the folded plates of steel. And then when a game starts, and this is incredibly dynamic as it goes around, and here you are moving into the arena. Here you can see I was very similar to the renderings. This is the main entry vom, the lights and the concourses. The black bowl. I mean, this was just so awesome. Needless to say, the owner of the Knicks can't stand us right now because the New York Times said, well, at least New York has one first-class arena in town. Madison Square Garden is now the dump of New York. The VIP entry, the different clubs. This is the vault space. This is the super exclusive club underneath. This is actually Jay-Z's suite. Blue Ivy has a playpen in there. And here you can see that we used boxing lighting instead of typical court lighting to really make it pop. It's got a herringbone, super dark floor. And the black and white uniforms, they went from 26th in the league in sales to 5th in the league in 5 months. It was worth tens of millions of dollars. So I'll go through this. I mean, so now the client's given us these first towers. These are going to be the 3 tallest modularly constructed buildings in the world. We're already under construction on this first one, completely made in a factory. I'll talk about this more on Thursday. Here are the mods. But again, thinking about real estate, all the things that architects can do, whether it's real estate development, whether it's thinking about new ways of constructing, whether it's developing software. Our first product that we're working on is a zoning analysis software that does investment metrics, 3D massing, zoning code, and GIS, brings them together. So you can mass any building. This is something that takes 4 to 6 hours going through the zoning and building code. You can do it in an online portal in less than 60 seconds and output your 3D model to your software and your square footage plates to your pro forma simultaneously. We hope to bring this to market next year. To some sustainable technologies. This is a dynamic solar curtain wall that we're working on. It's an array of Fresnel lenses that go to super collectors and tracks the sun during the day. And so the point is that we're not calling for a new period, a new style, a new method of working, or anything like that. But what we are saying is that this is an amazing time to be a young architect. I think that with the technology, you have a paradigm shift, and a paradigm shift means opportunity to reinvent the way in which we practice. And as I said before, we are amazing generalists, and we don't want to give everything away. We've systematically given away territories that we really should be involved in, if not in control of. And that kind of collaborative working process and rethinking that kind of animosity between the major players really allows you to push design. And that the more and more that you understand the finance, the politics, the technology, I believe the more and more you get freedom on the aesthetics and the beauty and the art. And by taking, and architects need to take more risk. We are so risk adverse, and that's really not the way to do it. The way to do it is to try these things. Lots of those development things that we did were failures. It didn't matter. We invented projects for ourselves. We tested ideas. We were able to challenge what we were doing. And I think that the more and more we try this as a profession, because I think we have so much to offer. And quite frankly, the most sustainable thing that we can do is not hang photovoltaics on buildings. It's to build buildings that people love, that they don't rip down or renovate every 10 or 20 years. We have to make things that are more dense. The most sustainable thing we can do is live in dense environments and then leave nature alone. But if we're going to make these dense environments, they have to have a great quality of life. They have to be beautiful. They have to have fantastic public space. And I think that architects are uniquely positioned to solve those problems. And these are major problems way beyond what buildings look like, really major problems about how we're going to live. And so in closing, I'd just like to say that if you're willing to take the risks, if you're willing to challenge what we are as a profession and what we have to offer to the production and making of space, it's very easy to go from this to this to this in 15 years flat. Thank you very much.
Thank you, Greg. Tour de force. There's little to say after that. It is important to keep that last message in mind, that I think we are on the precipice of new opportunities, and you've shown us how, through incremental steps, you've taken advantage of that. There are many other ways of doing it, and we encourage all of our students, all the practitioners, to think about that. So thank you very much for coming to Melbourne and sharing your experience with us. Remember, on Thursday, 4:15, there would be an opportunity to engage in more discussion about this. Questions might be allowed then, but we're not holding questions tonight. So thank you very much for coming this evening, and perhaps see you on Thursday.